For years, connecting an AI agent to an external API required a significant amount of boilerplate. Developers paid a high integration tax, spending hours writing explicit function schemas and API wrappers to bridge the gap between models and data. The Model Context Protocol, or MCP, provides an architectural solution to this friction. It replaces custom wrapper code by standardizing tool interfacing over streamable HTTP. This diagram illustrates the reduction in code footprint. A massive block of traditional Pydantic schema code on the left is replaced by a clean 6-line configuration block on the right. By removing the need for explicit function definitions, the agent manages orchestration through declarative configuration, moving away from imperative scripting. To see this in practice, we can track an agent navigating a complex multi-domain workflow in exactly 100 seconds. The process begins with a single natural language query regarding a specific geographic location. The goal is to reach a specific final output, actionable carbon credit economics and registry timelines. In this environment, there is no pre-programmed routing logic connecting the geographic input to the economic output. The agent runs on Leaf Engines MCP implementation using a free tier. Deconstructing this specific runtime trace shows how MCP enables agents to autonomously map and execute cross-domain workflows without manual chaining. The trace starts when the agent pings the MCP server using that minimal configuration. Through auto-discovery, the agent autonomously maps a directory of 10 instantly available endpoints. 4 of these tools are freely accessible and require no evaluation keys, removing initial access barriers. The agent receives the user's initial input string, Napa Valley. As this informational sign shows, the query begins as an unstructured real-world location. In this node graph, the agent starts at the query node, selecting the county lookup tool. It translates the natural language Napa Valley into a precise FIPS code, 06055. This converts the unstructured text into an indexable numeric format, necessary before querying complex databases. This autonomous translation shows that the agent handles its own state preparation, removing the need for developer-written data normalization functions. The agent now holds the FIPS code, 06055, within its context window. It evaluates the remaining requirements and routes that FIPS code into the Get Soil Data endpoint. This endpoint interfaces directly with the Department of Agriculture. The USDA building marks the transition from a local query to a federal database. The database returns granular data. Just as the researcher examines the soil in this image, the agent extracts USDA soil composition and local pH levels. It also pulls the area's organic matter percentage and drainage class. The agent handled this response without a developer writing a single callback function or JSON parser to interpret the USDA data. The agent independently formats this raw data into a context block for the next phase. MCP's unified protocol avoids brittle variable passing, typically required to bridge geospatial queries with agricultural databases. The agent begins tool call 3, feeding the compiled soil data into TurboQuant. Using extended context, the model applies reasoning to jump from raw data to a practical strategy. The node graph expands as the TurboQuant node outputs a complex array, providing AI crop recommendations tailored to the specific soil profile. The graph links the agricultural output directly to a final node, the carbon math engine. This final calculation extracts the exact tons of CO2 equivalent. It then assigns a specific dollar value to that carbon tonnage. Finally, it generates a practical registry timeline for realizing those carbon credits. These 4 disparate endpoints were synthesized into one coherent answer through the agent's runtime reasoning. In this single session, the agent executed 4 independent tool calls with high metric density. This diagram shows the LLM core connected via MCP to 4 different domains. This single session resolved 2 locations, fetched 3 datasets, and ran a complex calculation. This centralized graph replaces the scattered, manual API requests often required by legacy architectures. Crucially, the developer performed no manual chaining or state management throughout the trace. Declarative access management has replaced the need for imperative workflow execution. Engineers now focus on curating high-quality endpoints, as the need for writing intermediary glue code diminishes. This trace ran on the Leaf Engines free tier without signups, showing a lack of deployment friction. This multi-domain abstraction is ready for use without heavy SDK integration. The Model Context Protocol has decoupled the execution of external tools from the application layer, accelerating how AI systems are built and scaled.